Good morning. In today's lesson, we're going to be looking at forming the derivative of both products of functions and quotients as well. So in these formulas, here, u, v are functions of x. So if we have two functions of x multiplied together, we use the product rule to form their derivative with respect to x. In this way, we take u and we multiply it by the derivative of v, and to that we add v after multiplying it by the derivative of u. In terms of notation here, I'm using the simplified versions, u prime and v prime. These are the same as having du by dx and dv by dx in these places. Okay, the quotient rule. So we have one function of x divided by another function of x. To take the derivative of this quotient, we take v, multiply it by the derivative of u. From that, we subtract u after multiplying it by the derivative of v. And then we divide that whole difference by the square of the original denominator v. Okay, so I'd like to practice using these rules with you now. We're going to look at 6 examples in total. So here is our first example. Okay, so this example can be considered two functions being multiplied together. So it happens to be the multiplication of two binomials. We could therefore consider this function here to be function u, and over here function v, like this. So the product of two functions. So if we're going to use this rule, we will need to know what we are using for both u prime and v prime. So I'm going to do those derivatives here off to the side. U prime. What is the derivative of 5x squared plus 2? It is 10x. Of course, it's 10x to the 1 plus 0. Okay, what is the derivative of v? Well, it will be 4x. Again, it is 4x to the 1 minus 0. So we now have both u prime and v prime. So in forming dy by dx or y prime, we simply substitute into this product rule. So it'll look like this. U is multiplied by v prime. Then we have plus v multiplied by u prime. So we get this expression right here. Now, of course, we can simplify that. We're going to expand the brackets. So using the distributive property, we're going to open up these brackets to get 20x cubed plus 8x. That's doing this, right? And over here, plus 20x cubed minus 10x. So we get these 4 terms, and we can use collection of like terms now. These are like terms, 40x cubed, as are these, minus 2x. So we can obtain this as our final answer. Now, instead of using the product rule on this expression, since they are just binomials, we could have first rewritten y itself by performing the multiplication. So first outside, inside, last, if we just multiply the binomials together. collect the like terms, and we'd get 10x to the 4 minus 1 x squared minus 2, like this. So instead of the multiplication of two binomials, we now have expressed y as a trinomial. And then we could find y prime simply by taking the derivative of the trinomial. And that would be 40x cubed minus 2x to the power of 1 minus 0. Of course, the derivative of any constant on its own is 0. And if you take a quick look, we of course obtain the same y prime whether we used the product rule or did not use the product rule. Okay, problem 2. This is clearly a quotient. We have a numerator, we have a denominator. Each is a function of x. This means that we call the numerator u always, the denominator v. And since we're going to be using this, we should form both u prime and v prime off to the side on our page. So the derivative of 5x plus 2 is 5. It would be 5x to the 0 plus 0. The derivative of 2x plus 3 is 2. It would be 2x to the 0 plus 0. Okay, now we have everything we need, a u, a v, a u prime, a v prime. So we're going to use our quotient rule to find y prime, or dy by dx if you prefer. So these mean the exact same thing, okay? dy by dx or y prime. So now let's go ahead and substitute into our quotient rule. So we begin with v. We multiply it by u prime. From it, we subtract u after multiplying it by v prime. In the denominator is the square of v, just like this. Okay, we don't expand the denominator at all. We're gonna leave it just like this, but we do want to simplify the numerator. So we're going to do this and this like that. Okay, so we're going to get 10x plus 15, and from that, we're going to be subtracting 10x plus 4. Okay, so the subtraction of 10x plus 4 like that. Okay, so the numerator now will have a negative 10x followed by a negative 4. All right, and you could have done, you could have skipped this step and gone right to this one as long as you were very careful with your signs. See how they're both negative here? Okay, collection of like terms in the numerator is going to give us 11. So our final derivative is equal to 11 over the square of 2x plus 3. Okay, so that was a product rule used here, a quotient rule used here. Let's do some more examples together. All right, so here we go. Example 3. Now, example 3 must be viewed as a product of two functions. Here, we have a function containing x. So that's our u. And here, we have a second function containing x, and that is our v. So off to the side, we would form both u prime and v prime first so that we could then use our product rule. So the derivative of 3x squared is just 6x. Now, how do we form the derivative of v? It is a function of x raised to an exponent. So it's a power function. We have to use our chain rule. So you remember this from our last video lesson. The 3 comes in front. The binomial is repeated. The new exponent will be 1 less, which means it will be 2. And we have to remember to multiply that by the derivative of u itself. U is the inside of the bracket when we're talking about the chain rule. So we make sure we multiply here by 5. The derivative of 5x minus 1 is 5. Okay, so you do the exponent part first. Then you have to remember to multiply by the derivative of the inside of the bracket. That's called the chain rule. And that gives us 15 times the square of 5x minus 1. And now we're all set. We're going to write out our expression for y prime. Okay, so I will be using this. U times v prime plus v times u prime. So u times v prime plus v times u prime, just like that. Okay, so that's the product rule, u v prime plus v u prime. Now, in the simplification of this, we're going to use common factoring, but we might want to rewrite this first. These can be multiplied together to give us 45x squared in front of 5x minus 1 all squared. Here, we can write 6x in front of 5x minus 1 all cubed. And now we're going to identify what the greatest common factor is. For the terms themselves are separated by the middle sign. So this is all one term. This is all one term. What can they both be divided by? Compare the numbers 45 and 6. The greatest common factor for those numbers is 3. Compare x squared with x. The greatest common factor of x squared and x is x, so they can both be divided by x. And then compare this part. 5x minus 1 all squared is the greatest common factor. So we've identified a complete greatest common factor. It was 3x and 5x minus 1 all squared. So now what we want to do is actually divide this whole expression by this greatest common factor. So if you need to show this next step, you can. So I'll show you. You're going to put a square bracket, and then you're going to write back the previous line in here. Showing the division underneath each of these terms. Oops, sorry. Had a ruler and still went crooked somehow. But anyway, so we put this greatest common factor underneath like this. Okay, so you identify the greatest common factor. Then you divide each of the two main terms by that greatest common factor. So let's see what we get. If we divide this by this, we get 15. 15x. Then we put in the plus sign. Now we divide this by this. We're going to get 2 times 5x minus 1. Okay, so you can confirm that that's the case. Do the division like that. And now we just clean this part up a little bit. By doing this, right? So inside the square bracket will be 15x plus 10x minus 2, like that. So final answer in the next line. I can collect the like terms in this bracket. It'll be 25x minus 2. Okay, and that's it. At that point, we're finally done. So, form U prime, form V prime, recognizing that we need the chain rule for V. Okay, so make sure you realize V is a function of x with an exponent, so we need the chain rule. UV prime plus VU prime, rewrite it. Okay, at that point, the calculus is essentially done. What we're doing beyond that is algebraic simplification. So identify the greatest common factor, divide each term by the greatest common factor, and continue to simplify. Okay, so I know this is going to take some practice, so we're going to do more examples together. Here is a fourth problem. Now we know that we cannot keep that radical sign in the denominator if we're going to be differentiating. So we replace that square root sign with a fractional exponent of 1/2. This function is a quotient currently. Now I could bring the denominator up, by the way, and change the exponent to -1/2 to create a product. I could then use the product rule. Okay, but I'm going to just leave this function as it is. So U and V, like this. And now I'm going to write out what U prime is and what V prime is. Okay, now U prime is simply the derivative of 3x, and it is 3. But just like over here, for V, we had to use the chain rule. Similarly here, for this V, we need to use the chain rule. V prime is formed like this. We start by bringing the 1/2 out front. The new exponent will be -1/2. And we have to remember to multiply by the derivative of the inside of the bracket, which is 2x. 1/2 times 2x gives us x. So we end up with x times x squared minus 1 to the -1/2, like this. So we have U prime now, and we have V prime now. So this means we're all set to use the quotient rule. Right here. So we're going to use this rule. We're going to do V times U prime minus U times V prime all over V squared. And this will be informing Y prime. So really important to change that notation there. Okay, so it goes like this. V, okay, V times U prime minus U times V prime. V prime is here. And in the denominator should be the square of v. So that's v, and we need to square it. Okay, let's check that we've got it set up right. V times u prime minus u times v prime over v squared. Okay. Take a quick look at that denominator. These exponents multiply together to give us 1. So we now just have x squared minus 1 in the denominator. Now in the numerator, let's rewrite it, realizing that the middle sign is here. So this term, really, you might just want the coefficient in the front of it. Okay, that's much more natural. And then we have our subtraction sign. In rewriting this term, we should of course make this 3x squared. Like that. Okay, so now it's time to do the common factoring in the numerator about this sign here. So in comparing this and this, you can see that the 3 is common. You can also see that x squared minus 1 is common. You have to always remove the smaller exponent. Okay, up here we had a square and a cube. The square was identified as part of the greatest common factor. Here, when you're comparing 1/2 and negative 1/2, you remove the negative 1/2 exponent, always the smaller one. So the greatest common factor will be 3 and x squared minus 1 to the negative 1/2. And now you use division to work out what will be in the square bracket. So I'm going to set up a square bracket now, and I have to show let's put the denominator back. Okay, so the denominator can stay. It's x squared minus 1, right? This guy here, bracketed or not, whatever you like. Okay, now we're working out what will be left from here if we divide it by this. So if it's helpful to you, you can put in this step where you actually write that whole original numerator and show each term being divided by this greatest common factor. Like that. And also here. Like that. Okay, so this step right here that I'm showing is optional. If you don't need it to arrive at the next step, you can leave it out. So essentially what I'm doing is after I identify what the greatest common factor is, I'm going to use division to figure out what is left when we remove that greatest common factor from these terms. Okay, so what do we have inside the square bracket? Here, if we perform the division, you should see that the 3's will cancel, and we will get x squared minus 1 to the 1. Because when you divide these powers of the same base, you subtract exponents. 1/2 minus negative 1/2 gives you 1. Now we have this middle subtraction sign, and we're doing the division here. This time, these will cancel, the 3's will cancel, and all I will have left is x squared. Okay? Now we still have underneath that x squared minus 1. Okay, so as I said, this step here is optional. If you're able to go from here to here without it, then you're encouraged to do so. What you're doing is you're saying, if I take this and divide it by this, I will have this back. In goes the middle sign. If I take this and divide it by this, I will get x squared. Okay, now look, inside this bracket now we have x squared minus 1 minus x squared. It looks like we're just going to have a negative 1 inside that bracket. I can show you that step explicitly if you like. So what I'm saying is in this bracket now, if we just drop that outer exponent, we're going to have x squared minus 1 minus x squared like that. So that's going to just be a negative 1. So we have negative 1 multiplied by 3. So negative 3 is in the numerator now. Like that. And these are powers of the same base, so we should collect them. So in particular, you can envision this dropping down to the denominator. Remember, we want our exponents to end up positive. So if we bring this down to the denominator, it would be a positive 1/2 exponent down here. So we have an exponent of 1 down here currently. This comes down to join it. So I can show you that. I'm running out of a room here, but I'll show you anyway. I'm just going to write smaller, but that's probably okay because you can zoom in a bit. Okay, so I'll leave the negative 3 up top. If we bring down this x squared minus 1, it will have an exponent of 1/2. And down there already is x squared minus 1, whose exponent is 1. So in the end, in the denominator, we get an exponent of 1 plus 1/2, or 3/2. So negative 3 over x squared minus 1 to the 3/2. And lastly, we can write that in radical form. Okay, the 2 is the index, so it's square root, but underneath then we have x squared minus 1 cubed. So we get negative 3 over the square root of x squared minus 1 all cubed. Okay, so that was example 4. Now I know these can get pretty involved, so I'm going to do 2 more with you. So this video will be a little bit lengthy maybe, but I think that it's very worthwhile to go through them together. Okay, so problem 5 is here. So hopefully you can identify that this would be a quotient since we have a numerator and a denominator. So here's u, here's v. Now, in the examples 3 and 4, we used the chain rule once. And in each case it was to form v prime. But in this example, I'm going to need the chain rule for both u prime and v prime. Okay, u prime. The 3 comes forward. The new exponent is 2. And I have to remember to multiply by the derivative of the inside of the bracket, which is 4. So we end up with u prime is 12 times 4x minus 1 all squared. What about v prime? Chain rule again. So the 5 comes forward. The new exponent is 4. we multiply by the derivative of the inside of the bracket, which is 2x. So we end up with 10x in front. Like that. So we used chain rule for U, chain rule for V. Okay, let's use the quotient rule now to figure out y prime. Okay, so we will do v times u prime minus u times v prime over v squared. So v, there's v, times u prime minus u times v prime. Like that. Over v squared. Okay, so we've got everything set up now. All of the calculus is done, much algebra remaining, but at least we've got all this set up. So here we go again. V u prime minus u times v prime over v squared. Okay, the denominator now will have an exponent of 10. X squared plus 3 to the power of 10. These exponents multiply. Okay, now in the numerator, divide up that expression about the middle sign. So that's one term, that's the other term. Remove the greatest common factor. Okay, here we have a 12, and here we have a 10. It's 10x, okay? What's common to 12 and 10x? Only 2. Okay, what else is common to both sides about this sign? Well, 4x minus 1. Here we have an exponent of 2 and here an exponent of 3. Remember, the rule is you can only take out the smaller of those exponents. So 2. And then we have x squared plus 3. The exponents to compare are 5 and 4 respectively. Can only take out 4, the smaller exponent. And now we have to open up a square bracket and we have to fill it in correctly. Okay, so I'm going to try to do this without showing the explicit division like this. All right, see how you do. So what you want to do is take the left side expression first. This is the left side expression, and divide it by this greatest common factor. Okay, so you're taking this and dividing it by this. So divide the numbers first, right? Is 12 divided by 2, which is 6. Okay, now take a look at the binomials. Here, 4x minus 1 is squared. Here, it's also squared, so there will be no 4x minus 1 term. But what about this other binomial? X squared plus 3 to the 5 is being divided by x squared plus 3 to the 4. So that gives you x squared plus 3. And then we're done with that left side. So we did this divided by this, and here's our answer. Okay, if you hate that, you can even do it just on another paper. So we did the left side expression, okay, the left side expression, and we divided it by the greatest common factor. And when we did that, we went 12 divided by 2 is 6. We noticed this binomial would cancel, and then we said this binomial divided by this binomial, because the exponents are 5 and 4, we would get x squared plus 3 to the 1. Okay, so we did left side divided by greatest common factor. We got 6 times x squared plus 3, and we wrote it here. Now we have to make sure we put our middle sign in, which happens to be subtraction, before we do the next division. So next we're doing the right side divided by what we removed here. Okay, so you're doing 10x divided by 2 is 5x. You're noticing that this binomial has the same exponent, so it would be gone. But this one, 4x minus 1, here is cubed and here is squared. So we would get a 4x minus 1 here. Okay, if you're having trouble doing that, again, you can just write it on paper. So just write down the whole right side. And when I say right side, I mean it's to the right of the middle sign. So that's the whole right side divided by what you identified as the greatest common factor. And then you can say, okay, that cancels. 10x divided by 2 is 5x. And here when you divide, you will get 4x minus 1 to the exponent of 1. Okay, and I should mention there will never ever be exponents other than 1 inside this square bracket if you have formed the derivative correctly. And that's because this is a quotient rule that we're doing right now. That's because u prime and u have exponents that differ by 1. V and v prime have exponents that differ by 1. And why do they differ by 1? Because when you take the derivative, what you're doing is subtracting 1 from the exponents. So u and u prime have exponents that differ by 1. V prime and v have exponents that differ by 1. So whenever you do the step where you're removing the greatest common factor, you should not have exponents on these binomials other than exponents of 1. Okay, so if it helps you, you can do this kind of thing, left side, right side, on a paper to figure out what to put in here on the left side and the right side of that middle sign. Okay, let's continue to simplify here. So I'm going to work out the inside now of that square bracket. So what do we get? We get 6x squared plus 18 minus 20x squared plus 5x. All right, which is going to be negative 14x squared plus 5x plus 18. Okay, so it's negative 14x squared plus 5x plus 18, like that. And lastly, we've got x squared plus 3 to the 4 here, x squared plus 3 to the 10 here, so we can reconcile those to give us x squared plus 3 to the 6 in the denominator. And that will finally be our final answer. Okay, so down here, x squared plus 3 will have an exponent of 10 minus 4 or 6. Okay, that was a very long example, I know, and it's because it was a quotient and we used chain rule on both u and v. So let's do one final one together and then it'll be time for you to try some on your own, okay? So in example 6, the first thing, of course, we have to do is eliminate the radical. So we're going to make this 2x cubed plus 1 to the 1/3. Okay, so the index is always the denominator. The exponent on the binomial was 1. So now, of course, this is our u, and this is our v. And we are going to use the product rule. This is multiplication implied right here. So chain rule for u, chain rule for v. So let's do it. U prime. So the 1/3 comes forward. We do 1/3 minus 1 for the exponent. We multiply by the derivative of the inside of the bracket, and that is 6x squared. 6x squared times 1/3 is 2x squared. So now u prime is settled. Let's do v prime. The 3 comes forward. The new exponent is 2. What's the derivative of the inside of the bracket though? It's actually 0 minus 2x. So it is negative 2x. 3 times negative 2x is negative 6x. Okay, so now we have both u prime and v prime established, and we're going to use the product rule, which goes like this. U, oops, that's a 3, sorry. U times v prime plus v times u prime. Okay, so every time you write this out, check it to make sure you've got it set up correctly. So u times v prime plus, because it's product rule, plus v times u prime. Looks good. Okay, and now we're supposed to identify the greatest common factor, and we're doing it about this middle sign. Okay, so first you can compare negative 6x with positive 2x squared. So from those terms, you could either remove 2x or negative 2x. It doesn't matter, it's kind of your choice. I will remove negative 2x. Okay, so I'm going to be dividing them both by negative 2x. Okay, next, compare these binomials. 2x cubed plus 1. The exponents are 1/3 and negative 2/3. Always remove the smaller one, so that's negative 2/3. Finally, compare this binomial. The exponents are 2 and 3. The smaller of those is 2. Okay, so this is the greatest common factor. I have to fill in now this square bracket, writing down what's left from the left side after I divide it by this. Then there'll be a plus sign in the middle, like this, and I have to identify what is left from this side after I divide it by this. Okay, now if you want to, you can do it, remember, on a piece of scrap paper. So I might as well do that as well. So you basically are going to write down the left side stuff. That's the left side term. It's u times v prime. And you're dividing it by what you identified right here as the greatest common factor. Okay? You should notice that these match and will be eliminated. And then you do this. You do negative 6x divided by negative 2x is 3. And then you're going to divide 2x cubed plus 1 to the 1/3 by 2x cubed plus 1 to the negative 2/3. What happens when you divide, you subtract exponents. So it would be 1/3 subtract a negative 2/3, which is 1. And remember, I told you this will always, always, always turn out to be a 1. So this would go here. Okay, with an implied exponent of 1. So we just did left side divided by greatest common factor. We got the result and we wrote it here. Okay, the middle sign is now here, and we have to do the same thing for the right side. So we can write down the expression from the right side. There it is. Okay, so everything here. And again, what we're doing is dividing that by the greatest common factor. Okay, so that's the right side stuff divided by the greatest common factor. Okay, so we do 2x squared divided by negative 2x. That's negative x. Notice that this binomial now matches exact same exponent. So now all we have to do is divide 4 minus x squared all cubed by 4 minus x squared all squared. And of course, that's going to give you 4 minus x squared to the 1. 3 subtract 2 gives you the exponent of 1. Okay, so 2x squared minus 2x, you could do this instead, right? It's x squared divided by negative x is negative x. Okay, so this has to go here. Minus x times 4 minus x squared. And that would be to the exponent of 1. All right, we're not done quite yet. We've got to do our simplification inside of the square brackets. Okay, so it's going to be 6x cubed plus 3 minus 4x plus x cubed. Okay, or 7x cubed minus 4x plus 3. This can drop down because the exponent is negative, so we create a denominator, and it will be in the denominator. So we're going to have negative 2x And then 4 minus x squared all squared. So stays on top, stays on top. And in here, 7x cubed minus 4x plus 3. And what are we doing? We're dropping this down here, 2x cubed plus 1, so that it can have an exponent of positive 2/3. And so in the very last step, we'll use radical form there. Okay? So we're gonna have a radical here with an index of 3 and an exponent of 2, and then all this stuff is still in the numerator. Okay, and if you had selected positive 2x here, instead of negative 2x, then you'd have positive 2x here, and you'd have all three of these signs different in here. So you'd have a negative term, a positive term, and a negative term. And that would be 100% appropriate as well. Okay, I know that was a lot. 6 examples in total. In the algebraic, simplification is not particularly easy. So please take time to watch these examples more than once if you need to, and do begin to try the exercises that I have suggested. I've posted those recommendations for you in Blackboard as well. Okay, thanks and have a great day.